Alright, ladies and gents, welcome to Chapter 8. Chapter 8 is going to be focused on polygons, and what we are going to be talking about in this chapter is how to classify polygons. Classifying polygons, I'm talking about describing different polygons, ways to describe different shapes that we know as polygons. So there are three words that I want you to start writing down. So please pause now and write these three vocabulary words down, and then I will discuss them. So take time right now to pause and write these down. Alright, so now the very first one we're going to be talking about is going to be equilateral. Equilateral are polygons that have all sides are congruent. You may be similar or familiar with the equilateral triangle. You know that equilateral triangles are going to be triangles with all the same sides that are congruent. Okay, equiangular. Equiangular is, if you look inside equiangular, you will see that root word of angle. A little different spelling, of course, but you will see that it does almost form the word angle. Equiangular is going to be all interior angles. We're going to get to exterior and interior angles a little bit later on in this chapter, but equiangular, focusing on all interior angles, are congruent. Another one, regular. A regular polygon is a polygon that is both equilateral and equiangular. And in your minds, you might be wondering, okay, Mr. Sheeman, how in the world can an equilateral shape not be equiangular? And I want you to think about that wonderful shape that we have talked about being the rhombus. Remember, rhombuses are classified as a quadrilateral that has all sides congruent. Not all angles, but all sides. Okay, because you're going to have different angles, right? Different angle measures right here and right here. Okay, so there is a shape that is equilateral but not equiangular. Now on the flip side, equiangular but not equilateral, I want you to think of the shape of a rectangle. Know that a rectangle has four 90-degree angles, but it does not always have all congruent sides. If it had all congruent sides and 90-degree angle, what shape would it be? Of course it would be a square. But a rectangle is going to have two opposite sides that are congruent, but they are not all the same. So there is a polygon that is equiangular but not equilateral. To concave and convex, please write these statements down, pause, and we will go over them in just a moment. Alright, concave and convex. A polygon is concave if any part of a diagonal contains points in the exterior of the polygon. If no diagonal contains points in the exterior, then the polygon is convex. A regular polygon is, and notice this word, always, always, always convex. A regular polygon is always convex. So once you see a regular polygon, remember, regular polygon, going back to your a couple vocab from the slide before, a regular polygon being both equilateral and equiangular, those polygons are always convex. Now, what is the difference between a concave and a convex? I just wrote them down, but I have no idea what you're talking about. Okay, what a concave, I want you to think of that word cave. Concave is going to be a diagonal. Remember, a diagonal is a segment that joins two non-consecutive vertices of a polygon. So if you look at this shape on the left, that's a concave quadrilateral. There's going to be a vertice here and another vertice here. When we connect them with our diagonal, we notice that those points that connect the two vertices are on the exterior, are on the outside of the shape. Okay, so because of that diagonal forming on the outside or the exterior of the shape, that is concave. Also, if you notice right here, it's an indent and it kind of forms a little cave-like shape. Okay, if you look at convex shapes are going to be points that have all their diagonal points on the interior, on the inside of the shape. So if you connect all of your diagonals, remember diagonals are going to be a line that connects two non-consecutive vertices. Our diagonals here connect two non-consecutive vertices but are always on the inside. Okay? Convex, inside, concave, outside when talking about diagonals. Moving on to a couple examples. Now, these are going to be similar examples that you will see in your homework. It's going to be a simple question that just says, decide whether the polygon is concave or convex. Please take a moment, pause the video, write this down, and if you can, see if you know if they are concave or convex. Alright, come back here. We have decide whether the polygon is concave or convex. Now, if you remember, concave, the definition of a concave polygon is any part of a diagonal that contains points in the exterior of the polygon. Convex, all the points are going to be, or all the diagonal points are on the interior. Okay? So, when we look at this first shape on the left, you will notice if I drew a couple of diagonals to my non-consecutive vertices, my points are going to always lie on the inside of that shape. So we know this shape on the left as a convex polygon. Okay, so that polygon is going to be convex. Now, on the right side, you will see that this shape, you can actually connect two non-consecutive vertices here and here. If we connect them with the line, as you see with my wonderful dash line, not exactly straight, but you will see that those points are on the exterior of the shape, on the outside of the shape. Okay, so when we have a diagonal that connects two non-vertices on the exterior of the polygon, that is going to be known as a concave polygon. Alright, notice that right here you see that beautiful, right there, that wonderful cave looking shape. It looks like a bear's about to come up. Okay, that's a horrible bear. Ignore that. We'll just do roar. Okay, there we go. Alright, now moving on to our next slide. Looking here, I want you to look at this. It says decide whether the polygon is convex or concave. Then decide whether the polygon is regular. Now the next piece of this, there's actually three pieces to the problem. First, figure out if it's convex or concave, then decide if it's going to be regular or not. You can put irregular if you want, you don't have to. Then look at this wonderful sentence. It says explain your answer. Make sure you explain how to do it, or explain your thinking. I don't want it to be trying to guess what you guys are thinking. I'm not a mind reader. You already know that. Awesome. Okay, so take a moment right now. Write these notes down. Notice that wonderful yellow bar at the top. That means you are writing them down in your notes. Okay. Pause this, write it down, and then come back and see if you can come up with the correct answer. Alright, now looking at these, we are going to be deciding whether these are concave or convex, then deciding whether it's regular or not, and then explaining our answer. So if we look at this very first polygon, okay, concave or convex. Well, even before I look to see if it's concave or convex, I will notice that I have all congruent angles. I also have all congruent sides. Okay? When I have all congruent angles, I have all congruent sides, I have a regular polygon. Okay? So this is going to be regular. And because it is regular polygons are always what? You got it. They are always convex. Wonderful convex polygons. So now we have a regular polygon. We have a convex polygon. Why do we know it is a convex and a regular polygon? Well, we know that is equilateral, is an equilateral shape, and it is equiangular. Equiangular. Okay, so right there I have my, is it regular or not? Is it concave or convex? And I have my explanation. Those three parts of the answers I want to see. Okay, flipping over to that next one. Okay, looking at this next shape, you will notice very first thing, okay, I'm looking at it and I'm looking at my angle measures. Alright, all my angle measures are going to be the exact same. Alright, then I look at my sides. Notice that my sides here on the top and bottom are different than my other side lengths. Because of that, okay, because of that, we know that it is not regular. Alright, so is it not regular? Then we can focus on, is it going to be concave or convex? Well, if I tried to connect all of these wonderful diagonals that I know you guys are thinking of, connecting all these beautiful diagonals, okay, I could go through the entire shape, but we will notice that all of these diagonals are going to be on the interior of the polygon, meaning this is also a convex polygon. Now, convex polygon, not regular. You could also put irregular. That's not a big deal if you want to put irregular and just skip that word not in front of the regular. Then you go to explaining your answer. We know that we have all angles the same. We know that this is an equiangular shape. Equiangular shape. Then looking at the sides, but it is not going to be equilateral. So not equilateral. Okay, so right there you can put that in parentheses if you'd like. So on the left side you have a regular, good example of a regular pentagon. A regular pentagon. Okay, that is convex, and we know a regular pentagon being equilateral and equiangular. Now on the right side you see a beautiful drawn shape of a hexagon. Look at that beautiful drawn shape by yours truly. When we look at this, it is not regular, it is convex. The only reason why it is not regular is because it is not equilateral. Equiangular, but not equilateral. Alright, so that's all I have for you guys tonight. Short, quick lesson, couple of notes, not too much. Now come to class tomorrow, be prepared to do a few examples and start your homework. Thanks, guys.